in live today we do 50 deployments per day what we deliver. So more statistics, bear with me. So what does it mean? So if the developer comes to work at Pipedrive, we're gonna assign 2 microservices. Or if we don't have anything to assign, he or she gonna build it. And developer is busy at least 1.5 times per day to deploy it. At least 35% of microservices our developer will change and deploy in weekly basis. So we, as a big bank presenter, we do automated builds for base images. Well, we haven't automated that part because our developers are so efficient to do it themselves. So we're gonna hire more developers to run deployments. And but we spend 6 minutes, so 9 minutes per day we spend for the deployments. That's how our developers work here. 10 minutes, yes. All right. So now let's finish about boring stats. So I wanted to talk about the sandbox environments and what are those. So why we need them here. So basically, before we, as I mentioned, we do so many changes in live, we need to test it out. So to be sure that we don't make our 80,000 customers unhappy. So we need to test it in some isolated environment at the same time when all other 200 developers are doing. So if we have managed to test it, we want to share it. Maybe new feature has been created, and let's share with other colleagues and see what they think about it. And all about this, we need isolation to just to test something. Easy to line of code, what has been updated. Is it some library update? Maybe it's some infrastructure component, some the database versioning updates to see what is this. So it has to be executed somewhere, and it's better if it's done outside of this machine, and otherwise you have all heard about it. It works in my machine. So we have remote environments, we call them Sandbox. And before we came up with a fancy solution, what we did, we provided 1 to 2 virtual machines per team. So it means that before, if we had like the 10 teams, it means that we required like at least 15 virtual machines, and they were quite huge ones. 3 years ago, when I joined Pipedrive, those virtual machines were very small. It took like only 2 CPUs and 4 gigabytes of memory. But as we added more and more features and more services and even databases, when they started to grow huge, we ended up 8 CPUs and 32 gigabytes of memory, and most of the time they were still idling. And to manage those virtual machines, it was pretty much manual work with or semi-automated work. We had the provisioning script. It took like 45 minutes to build it, and sometimes it failed due to some configuration issues which were outdated. Or if you remember, we have 400 projects, and every developer spends like 1.5 times to update something, when immediately after provisioning this virtual machine was outdated. We didn't had anything how to keep our projects to synchronize beside our manually executed scripts. And finally, if there were some issues, it took some time to go and investigate. For us, it was even faster just to let's run this provisioning script and hope that everything will be fixed when go and see what it wasn't 400 project back then, but maybe 200 plus databases to see what happened to it in the middle of the development and testing cycle. So we went to a scratch board and we came up with a new brand word called the Testboxes. So if we hear Testbox, we mean it's a sandbox environment. So in our development cycle, we have a local environment here, then Sandbox, which represents as much as possible production environment, and after that we deliver code into pre-production, which is an identical copy of production environment, and went live. So what we did, instead of virtual machines, we dropped virtual machines concept at all, and we deployed the Docker Swarm cluster. Yeah, Equalizer is working. So, for example, in one cluster, we have the 10 Docker instances, and we are using Enterprise edition. But you can build the same concept with open source Swarm as well. So, one service, one microservice is mapped to Docker service. So Docker service is abstraction of running container, keeping it up and running if you need to have multiple instances. So Kubernetes people should have same basis for services as well. And we group them together as a stack, so meaning all necessary services like web application, backend applications, rapid queuing management, the databases are grouped together, and they are here. It's pretty much metadata virtually grouped as a one concept. And all containers or services are attached to overlay network. And the overlay network creates sort of not tunneling, but the virtual network between the Docker host, so that if a container is deployed to a last Docker host in the cluster, it can communicate with all other containers in a different host. And this is in our organization, it's the only place where we use those virtual overlays. So how we now manage those, or how we can make this management more convenient. So we still use Jenkins for deployment. So deployment to live and pre-production environment is we reuse with the same pattern. Now, first time we run stateful services with the databases, and we store the state in the external storage. So for us, it's a NetApp appliance. Works pretty well so far. Maybe there is a hope for containerized database services. We use Graylog to collect all the logs. So we have one Graylog engine for all Testboxes, all containers here. And there is some magic proxy like traffic from first presentation, but we somehow ended up using Dockerflow proxy, but it pretty much does the same thing as the traffic. And this is used so that we can externally access our services. And finally, there is the magic orchestrator. and Georgi will tell all about it.
So, hello, I'm George. I also work in this building, believe it or not. I also should have some fun facts about Renno, just a second. So, in his free time, Renno loves to do circus stunts with aerial silks. If you haven't seen a video of him performing those stunts, please ask him. I was pretty shocked when I saw it the first time when I came here, but still, yeah, quite a fun activity. So, what I'm going to talk about in the rest of the presentation is that I'm going to guide you through the thought process, how we created this solution, and what is the most important parts for us to solve and the painful problems. When you think about something like a solution which you need to create, you need to think about the bigger picture from it first, right? And one of the important helpful things there is that you need to imagine the life cycle. What will be the life cycle of your solution? And when we talk about on-demand testing environments, the first thing probably is you need to create your environment, right? You need to bootstrap it. You need to run some automated scripts. You need to request the certificates. You need to prepare everything. After that, you're going to use it. So you have full freedom in your Sandbox environment. You're going to nuke it down. You want to run tests. You want to run some experiments. You have full access and it's fully isolated. So you're free to use it however you want to. And last, you want to destroy it. So you need to undo everything which was created by the creation step, so that by definition, this environment needs to be on demand, which means that this resource needs to be available again for further use. So we came up with the lifecycle, which covers everything which we needed for our solution. So some of the steps here are not visible for the user, but they are only used by automated processes. So in the start, we only have like an empty Docker cluster where this compute resource is available and we need to do something with them. So we take those resources and we provision our test boxes by deploying the services which are needed there. This provisioning process bootstraps the environment and prepares everything automatically. Once the test box is ready, I think this is the one. Once the test box is ready, the users or our developers or engineers can request them on their own. Once test boxes are requested, they are further customized by developer needs. So the developers have a way to define what they want to do with the test box, what services they want to deploy. And at this stage, we further customize the test box according to their needs. After that, we think that the test box is taken. By default, the TTL for a test box is 1 day, but the developers or engineers who request the test boxes have a way to further increase this time. But the default 1 day is quite useful for us. And in the end, when you're done with your environment, what you destroy it, right? So we have a term here, we call it rotten. And when we say that the test box is rotten, which means that we can dispose this environment. We can delete the environment and we can return the resources back to the cluster so that they can be taken again. And if anything fails during this process, we say that our environment is failed and our automated scripts are trying to reprovision them again. That's about the life cycle. So another important part, Orchestrator. Now, when we thought about this life cycle, we really don't want to spend our time doing it manually. And we realized that we need someone to take care of this environment, and it won't be us because it's like too much manual work. So we came up with the concept of Orchestrator, which is a software layer which manages the test boxes. It handles everything which is related to the test box lifecycle. Any events which come from the lifecycle, updates to the services, everything is covered by the Orchestrator. Additionally, for example, the Orchestrator requests the certificates because our test boxes are under SSL fully. So all microservices are accessible by the certificates, which means that they need to provision certificates on the fly, etc. Everything is covered by the Orchestrator. Now, we saw that some of the lifecycle events were taking really too much time, like let's say 10 minutes, but it's too much. We don't want our engineers to spend even 10 minutes waiting for something. So we came up with the concept of the pool, which means that we put all our test boxes in a single pool, and we actually have hidden all the test boxes from the user, but the user only works with the pool. The concept here is that we pre-provision the environment because we know what the developer will most probably expect. So we pre-provision the environment, and once the engineer requests the test box, he gets the pre-provisioned one. But once the test box is assigned, we pre-provision another one behind the scenes, which gives us pretty cool user experience. And in the end, the orchestrator is also responsible for integrating test boxes with other platforms. So our other platforms don't have direct integrations with the test boxes, but rather than they are integrated with the orchestrator, with the API. So now, UI. When you think about the UI, it's something like a fancy addition to the solution you created, but for us, it was more like a way to delegate the process to the users or our developers, because we don't want it to do anything for them, because they should have full control over the process and over the environment. So we added the UI to the orchestrator. The UI handles the interaction between users and their test boxes. Engineers or users have full control and full visibility over the environment. What does it mean? So they see all the microservices which are deployed there. They can add the microservices or they can remove them. They can see how many containers each service has started. What's the lifecycle? What's the health check status for specific service? They have full control there. And for us, the UI provides the visibility over the full status. So from the first glance, we can already understand like what's the usage, how many test boxes are pre-provisioned and ready for be taken, etc. So we really could not give everything to everyone, so we needed to come up with some kind of concept so that the engineers can further customize their needs, because we can't give all 400 projects to all the engineers. So we came up with the concept of templates, and templates means that we group our microservices in a logical way. We call them templates. We specify our microservices by their versions. The versions can be any source SCM revisions, or it can be some Docker tags, related Docker images. But the versions, together with the services, are grouped under templates. Now, what's the point of the templates? Templates are stored online in the orchestrator, and the users can access their templates from the UI. Once they want to request the test box, they just assign a specific template to the test box. We use that information to further customize the environment for their needs, and that's it. Developer or engineer gets exactly what he needed. The services which were not needed are removed from pre-provisioned test box, and services which were additionally requested are added at this point. Now, the most important part, at least for us, for the engineers working here, we really wanted to automate something because at that time we had an automation in our job title, so we really wanted to do something about automation. But in reality, the point with automation is that you don't want it's a manual work. It doesn't scale, and it's boring. And the history also shows that even in Pipedrive, for example, our previous solution had some processes which were relied on the human interaction, human process. And it doesn't scale, and it's always a problem. So with the test boxes, we decided that everything will be automated, and it is. So everything starting from the lifecycle events is fully automated, and all the deployments, environment bootstrap, certificates, service deployments, everything is also automated. Now the project has started 5 months ago in Pipedrive, and since that, we have only worked on the process environment, process improvements. This automation, why is this automation the best thing for us? Because we have more free time, right? We don't need to spend time on the user's request, and we can spend our free time when we want. For example, like drink coffee or play football there, etc. So this automation doesn't come from nowhere, right? It's a heavy work which was invested from the team. And as an example, to kind of see what's the behind of this automation, each test box provision currently triggers around 50 different Jenkins jobs, and it's powered by 8,000 lines of code, which is written by Pipedrive engineers. So it's a long process, but it gives us the best results. Now some numbers. What we got as a result in terms of numbers. It takes 2 minutes to create a test box, which means that if you go to the UI, you request a test box, you can go and take a coffee from the coffee machine, and once you're back to your desk, the test box will be ready for you to use. It takes 10 minutes to provision Testbox behind the scenes, and our pool or our orchestrator takes care of that. So once the Testbox is ready or the new resource is added, everything is dealt with. Everything is done by the orchestrator itself. Our pool is has currently 30 Testboxes. We hit some limitations with the Docker engines, which we tried to overcome somehow, but currently we are trying hard to increase the size. Of the pool, but it's not that easy because UCP and Docker engine are not playing well with high number of services. And currently we have around 2,100 services per our cluster. We have 10 hosts to manage all of this information, and 33 Testboxes are recycled per day, which means that all the pool is recycled per day, which is pretty high usage in terms of Pipedrive. Now, to conclude, what do we like about Testboxes once again? And that's it. So they are fully on demand. The resources are distributed according to your needs. If you don't use anything, you don't have to say anything reserved for you. Once you need something, you request it, and that's it. Everything is up to date. We have special watchers. Once the microservice is released to live environment, it's automatically being deployed to the Testbox. So when you get a Testbox, you have a guarantee that it's not outdated. It's constantly up to date. It can be easily tailored, which means that you get what you want. You don't get anything extra. You have a way to customize it, and you don't get any extra microservice. It's fully automated. There's no manual work. It's really fun for us because we have a service for which we are responsible for. Everyone thinks that we are doing some amazing things behind the scenes, but all we are doing is just thinking how can we improve. There's no manual work which we need to do in everyday life. They are fully isolated, which means that once you get the Testbox, you can nuke it down, you can destroy it, and don't be afraid that it will destroy someone else's life or someone else's day. You can do whatever you want with the environment. And it has pretty neat self-service UI, which gives full visibility over Testbox, and it's further expandable with the API so that it can be integrated whenever we need. That's it, some small demo currently. So this is how our Orchestrator UI looks. By default, you can see that there's a list of all the Testboxes which are available, the guys or teams who have requested them, what's the status, what's the TTL, how long they will be active. And we also have the information about templates, which you can see that those templates are created. It's pretty interesting thing that usually our engineers don't bother to create their own templates because they are fully okay with taking some extra microservices, but this feature is there. But like it was pretty interesting for me that it didn't found quite the wider usage compared to the other stuff. But we have templates available. Engineers are free to create them and decide what services will be part of these templates, those templates. So how do you request a Testbox? You hit a button, you decide, you specify what team you belong to. You specify the description. You specify the template which you want to apply. For in this case, I will just add empty template because I don't want any other customizations to happen. I don't want test users. I need it for 4 days, and I hit create, and that's it. At this point, now what happens is that our orchestrator takes a Testbox or environment from pre-provisioned pool and adds some additional customization to it. It will take a minute or so, and after that, I can actually really use it. But until that, you can see that all the services which were by default, which are needed by our service, by Pipedrive, are already there. They are added there, and you can see like the versions, revisions, Docker tags for each of them. Now, how can a developer change something? It's pretty easy. You just specify different revision, or you just specify a different Docker image and hit redeploy, which means that after that, you don't need to do everything. This new version will be available directly after that. And you have all the shortcuts or short accesses from here. You can see the health check status, you can see number of containers, etc. So each Testbox is fully isolated, which means that Pipedrive is running inside the Testbox. It's fully isolated, has its own environments. And if you change something, if you break something, no one else is affected except you. Now you can see that this Testbox which I requested went through the customization stage. Now, because I'm okay with the default, everything default, which was pre-provisioned for me, the customization stage will not take much time, and in a minute or so, it will be available for further use. Now, if I want to add or remove any additional service, I'm free to do so. I can specify, I can remove all the services from the list. I can trigger the tests. I can redeploy them if I need them. And once this is done, I can also show how new service can be added. Basically, only thing I need to specify for new service to be being added is just the service name, and that's it. By default, we always take the latest version of the service and deploy it to the environment. And that's it. The Testbox is taken. I can now access it with the UCP, see everything in the Docker, or see some short information here as well. Now, let's assume that like some days have passed. I'm done with it. I don't need it anymore. I'm okay to return this resource and delete everything. All I do as an engineer is just delete the environment from which, and at this point, the orchestrator will just pick up the Testbox, delete everything, undo everything which was done during the customization stage, reprovision the Testbox again from our scripts, put it into the pool so that it's again ready for usage or for assignment. That's it, basically. Thank you very much. And now is the time for questions.
Georgi, can you tell what UCP means?
Oh, yeah.
For the rest of the audience.
So I don't even remember how this abbreviation is like split. Unified Control Plane.
Universal Control
Universal
Plane.
Control Plane, great.
And what does it mean?
So it's the UI plugged into the Docker engine.
Yes, so it's a Docker Swarm UI provided by Docker Enterprise. All right, questions I heard. So first one.
So how was the orchestrator built? Like which language, how is that stack? There's 8,000 lines of code on that. So what is it?
So it's exactly, the orchestrator itself is around 4.5 thousand lines. It was JavaScript, but it was migrated to TypeScript. It's fully TypeScript. And the rest of the lines are related to the pipelines and deployments in Circle. Mostly it's a Groovy code, at least for now. Yeah, for deployments, we use Jenkins. And sadly, we still use Groovy for pipelines. But we are working hard and very hard to migrate from that to a different solution. And hopefully we will have a meetup about that as well.
So how do you manage the database part? So for example, when you deploy the microservice to a Testbox, and does it use like its own database, or does it use some sort of shared staging database? And like what happens? So if it's shared database, so what happens if there's some sort of migration, which kind of can break, like, or has some breaking changes basically?
So we assume that every service is responsible for their own, except migrations, there are some aspects like test data creation, preparing some environments for tests, etc. For now, we assume that everything needs to be done by the service itself. So the engineers or the owners of the service have access to console. They know so console is the service we use for service discovery or discovering the date pages, etc. And currently, our environment for test boxes is, so each test box gets its own database, so it's fully independent for each other, but the services itself are responsible for bootstrapping everything, like doing the migration, updating the environment, etc. And the seed data as well. Yeah, everything needs to come from the service. And it's kind of properly aligned with the microservices architecture as well, because everyone is responsible for their part, including the seed data. And we have an ideas about some improvements, and we want to, in the future, we want to allow users to run arbitrary scripts during the customization part to kind of make this part even easier.
About the cluster of Swarm, have a lot of limitations than Kubernetes don't have. For example, ES2, Linkerd, service mesh. Do you have plans to migrate to Kubernetes, or how you support these features that Swarm don't have in your roadmap?
So I'm gonna answer that. Yes, we are looking into when next problems what to solve. So one thing, but the existing problems, at least by last year, was that we were still migrating legacy architecture applications. So now that everything is containerized, we are looking again our infrastructure, what can we do better. So I would say that Swarm is not bad, at least not to begin, but the Kubernetes also has quite a lot of features and has a heavy evolutions with all those features. So yes, this year we are looking more into Kubernetes and see if we can reuse it. What in last meetups, what I have mentioned was that our choices, why we ended up with Swarm at all, was that when we started to build microservices, we first built service discovery and we selected the console. And as console was the first requirement that we need to support because console enabled us to unite the old architecture using virtual machines and containers together into one service discovery. So Kubernetes had already built in service discovery where we didn't see any advantage for us. We still had to integrate with the console. And back then, it was very easy to start with a single Docker virtual machine and add services from Docker container into console. Later, we just expanded to Swarm. And that's how we are still using Docker Swarm here. All right. Where was other question? Okay.
Can I ask you about Swarm? Why did you decide to use Swarm, especially after discovering console is so important for you for discovering? Why didn't you take, for example, HashiCorp Nomad and about Swarm? No, sorry. I'm a little drunk. About your Sandbox UI, do you have API? What if I want to run integration tests and set up many different sandboxes? Okay, let's start with.
All right. There are two questions. I'm going to answer one, and Georgi can answer the second. So. Back when we started our container journey 3 years ago, pretty much I was hired because I knew something about Docker, and that was all to impress here. The Pipedrive was very small as well, and it was really hipster technology. So Kubernetes was also very young. It wasn't even stable. Even Docker Swarm wasn't stable. The only mature technology was Apache Mesos. So who is using Apache Mesos? No one. Why aren't you using it? It has the best history so far. And yes, the Nomad has good traction in Germany, but as we ended up with Docker engine and containers and console together, we didn't see any advantages why to use Nomad in that case. Did that answer your question?
I understand that you have to migrate to Kubernetes at the end. Okay.
All right. Georgi, you can answer the second part.
What was the second part?
About API to your UI and multi-sandbox environment for integration tests.
Okay. So the interesting to answer kind of the previous question about Kubernetes is that we are relying, so a lot of our integrations, including the Sandbox environment, are relying on Docker API a lot. And we are reusing Docker API very actively, which means that when we want to add some fancy feature, usually the way we do is that we add it through the Docker API, including some additional customization options, which may be available at other orchestrators like Kubernetes. So the way we expand is that we add some business logic using Docker API usually, and they take the logic outside. Basically, yeah, the orchestrator itself has the API available, and the API gives us then functionalities like, for example, at least planned, like some of the cool features we want to plan is that we want to directly deploy the code and make it, let's say, part of the pipeline as well, so that the code before being deployed to the live environment can code by default through the test environment, etc. But this API is very crucial for us in that case.
Can you elaborate a bit on security? How do you restrict access to test environments?
Do you really want to know the answer? We don't. So if you have access to the, basically everyone has access to everyone's test boxes. It's not limited per se, which means that you're free to, let's say, modify someone else's test box. It's something which we are looking forward, but and the planning process, we thought that this is something which you can sacrifice in terms of features. So currently, it's not limited.
I have a more general question about Docker. There are several alternatives or competitors of Docker that have appeared recently, like Podman from Red Hat and Rocket, and probably something else. Could you please share briefly your opinion on that, and do you see them as real competitors in the near future?
I believe Renno will love to answer this.
Can you repeat again? I was searching for other questions, people who have questions.
There are several alternatives of Docker that have appeared recently. For example, Podman from Red Hat and probably something else. Could you please share briefly your opinion whether it will be a real alternative and competitor of Docker or something else?
So I believe that cloud user will use cloud provider features like Kubernetes. Amazon has own Kubernetes deployments, and like Google. So Red Hat customers definitely prefer Red Hat products like OpenShift, and I haven't really checked into his Podman features. So, and Docker and Red Hat are competing for enterprise customers. So currently, I see what one difference is that if you are using Windows containers, then today Docker Enterprise has a functionality for that. Anyone is using Windows containers? Only one? You should come and talk here. I want to see it. But I think that I can't tell publicly that one solution is better. It depends on the environment. It really depends on what are the requirements for this service. I can say about as much as for Docker that they are advertising that they are vendor neutral, but of course Docker will be another vendor. For us, why the Docker solution fits well for us is that we deploy our services in Amazon and Rackspace. Until a year ago, Rackspace didn't have like any managed Kubernetes solution. So we had to came up something, and today Docker Enterprise is one way how we manage our services in the different cloud and premise hardware providers like Rackspace. So I believe that if you're using a Red Hat solution, it provides the same solution. All right. Was there any other questions? Oh, yes, I have seen you. Can I have a box back?
You can throw it away. Oops.
Okay. So I have two questions. So how many years did it take you to build this, your demo stuff? And the second one is I saw there is a zone like tools. So how do you manage SSL certs for all that?
Great question. Actually, it took us. So if you imagine, it would, if one man would work at the solution, let's assume that there's a one-man team, it would take 18 months based on what we have worked. So we're working on this in a three-man team, and it took us 6 months to just build this, everything. The biggest problems which we had was that ideally everything between the microservices is fully isolated. So there's no hard dependencies and everything is zero configuration, etc. But there's always in the actual environments, there's always something which, where there is not documented, needs to be additionally added, etc. And we really spent some hard work on migrating or making all the services like fully isolated so that they don't have some hidden dependencies and they don't work and they're automatically deployed, etc. So that was like a huge time, what took a huge time. And another question was related to SSL. We use Let's Encrypt, default one. So we have some issues. We did some optimizations with the rate around rate limiting because we have a lot of them. For example, we cache SSL certificates for test boxes. We have some naming pattern for our test box environments, and we try to reuse this naming pattern so that we can reuse the SSL certificates. And the orchestrator is responsible for caching that part, so caching the SSL files and assigning them again with the test box with the same name. We use Let's Encrypt, we use Acme script, and we have built a wrapper around Acme shell script to do all of this. And the orchestrator is also responsible for renewing certificates. We track the expiration date for certificates and we renew them. And it's still not enough, it doesn't scale. So in the future, we are thinking about unifying multiple test boxes under same certificates with using SANs or some certificate alternative names. So that, for example, instead of one set test box or one environment having its own set of test certificates, we will unify multiple environments under one. So all those optimizations just around the rate limiting issues of Let's Encrypt.
Hello, I have two questions. First of all, at the beginning of the talk, you mentioned that we can also build the same structure with the open source edition too. Like, what is the difference between the enterprise edition and open source edition? If you decide to build it in open source edition, which part of this demo will be missing? And the second question is how you are managing the log, actually. Do you have a log server? I see that there is a gray log. And is it scaled well or?
All right, I start with open source form. So open source form doesn't provide any UI and user authentication to manage containers. So you can extend it using open source component Portainer, for example. It works very well. We even started with Portainer, but also because Portainer is quite a fresh or 2 years old project. We compared with the enterprise edition when my VP said that we have enough money to buy enterprise products, so we decided that we don't extend or fix all issues what open source version is lacking. So yes, today you can start with open source with container very easily if you want to test it out. With logging, so today Docker engine has you can ship all standard out and standard error to using log drivers. So we are using Kelp driver. So, but this is sort of like what it does. It sends line by line code to our Greylogs server, and it's not very user friendly to read some stack traces. So our services have requirement to use our logger library where it sends log with with enough information to Greylog. And Greylog in the backend use Elastic database. So it scales relatively well, but of course you can float it very easily if you don't manage your logs. Yes.
So about the logs, single Greylog per Testbox was too much an overhead. So we decided that Greylog, for example, this logging solution will be one of the solutions which are shared between the different environments. So each environment have access to unified single Greylog. And as for the features, everything that we are using based on the API, the only thing we are taking from the Docker Enterprise is just the UCP or this user interface. And if you have worked with the UCP, you have probably seen that it works so terrible that probably it will be better if we rebuild that UI as well. But basically, we have some information available from the UI. But if you want to have some details, let's say you want to see container IDs, you want to scale up, scale down. And if you don't want to use some kind of shell or something to access that, the UCP is the go-to there. And it's crucial for now. But it performs so bad that probably something.
Just to say that UCP performs terribly, but we are stress testing quite a lot. And last time when I tried to, if I can replace it with container in our environment, it performed even worse, unfortunately. Would like to save money. Any other questions? All right. But what? Automate everything. Yeah. I recommend automate. If you have quite a lot of repetitive work, automation is a one way to get rid of it.
So we have provisioning jobs, and like each lifecycle behind what I have showed has its own job. Let's say defined in part of the Jenkins. Each of those jobs have their own pipelines, which are also written by us. And a huge part of the automation is done with the Orchestrator. So it's just a pure software solution, which will Jenkins and Orchestrator. There's nothing else.
So configuration management is only used for operating systems. So we have dedicated team. We call them infra engineers. They take care of provisioning virtual machines. They install the operating system, patch it, and we install the Docker engine, copy all configuration files, and then they hand the cluster over to us. And we are the middle layer for the developers that they can easily upload their code changes and trigger the deployment and the test jobs.
So the Orchestrator directly works with the engine and the Swarm cluster, and it doesn't go even lower. So it's just that and something built on the cluster, nothing deeper.
We are sort of customer for infrastructure engineers. So if we need some operating system layer change, we request, or if we are brave enough, we go to chef repo and modify some configuration there. Okay, I think that should be all. So I'm really glad you came here. So who is coming next time? So who is going to talk? All right, you should when contact me what you want to say, and we can plan next event. So, and big applause for Georgi. Yeah, that's it. You can go to home now.